So this will be the last lesson for the organic chemistry unit. And a lot of it comes down to memorization, but not really, because the words that I'm going to be showing you and talking to you about, they kind of explain exactly what they're doing. So we're going to talk about organic reactions, and there are 7 of them in total. And I'm going to explain to you how to identify and know what they mean. So addition is the first one that we will be talking about. And it's exactly what it sounds like. We're adding something to a hydrocarbon. So by definition, and I tried to make these definitions as simple as possible, you're going to be starting with an unsaturated hydrocarbon, which means a double bond or a triple bond. And we're going to be starting with 2 atoms. Okay, this is like step 1. Step 2 is that the bond will break and the 2 atoms will be added to the chain. And so there's 2 examples I've done for you on each of these. I've given you I don't know why, first off, I don't know why this arrow didn't come through, but it's supposed to be an arrow here. I've given you a structural formula example and then just the molecular formula example. And both ways are pretty easy to identify what's going on. So I'm going to start with the picture. All right, you can see that we have this unsaturated double bond. And to it, we're going to add this Br. So these 2 reactants are in a vessel together. And when they react, the bromines break apart the double bond and then become added to the hydrocarbon. So we've gone from having an unsaturated to a halide with the addition of a diatomic molecule. Now, this is a perfect example of addition. It didn't have it. I added something to it, and not only did I add it to the reaction, I added it to the molecule. Addition. In the molecular formula, we would be able to identify this as a alkene because it fits that general formula. If you wanted to draw it out, you could, but I don't even think you need to go that far, because when you see this is bonding with or reacting with chlorine, and now all of a sudden has become one molecule where the chlorine has been added to the original substance, it can only fall under the addition reaction. And simply put, as simple as it can be, that's what an addition reaction is. The next one that we'll talk about is substitution. And it's kind of the opposite, but not exactly, because it's not subtraction, but it's substitution. So, I meant to write not substitution, or subtraction, sorry. We're not just taking something out, we're substituting it. So we're removing elements from a hydrocarbon. This could be a double bond, it could be a triple bond, it could be a single bond. And the key is that we're replacing them with something else. Just like, the one example I use every year is a substitute teacher. You have a teacher. What does it mean to have a substitute? We've removed your current teacher and we've replaced them with some other teacher. And that's straightforward, right? We had it and then we changed it. So if you look down here at the structural first, we see a hydrocarbon methane and a diatomic chlorine. And in the reaction, we've taken one of the chlorines and swapped them, replaced them with one of the hydrogens. And what we're left with is a hydrocarbon with 1 chlorine and hydrochloric acid left over. This atom substituted with that one. In the molecular formula, it's also really easy to tell because you can see this was C2H6 and chlorine. Arrow gives me C2H5. So automatically I know that one of the hydrogens is no longer there, and in place of it now there's a chlorine. Here's the hydrogen that was removed from here. This must be a substitution reaction. I do suggest, since I'm going to be posting this as well, that you either copy it first or pause the video or copy it later, watch the video, but just, go at your own pace. And a lot of you in the survey that I sent out did say to me, one of your biggest strengths was being able to take your time and being able to, pick it up, put it down, stop for 20 minutes, start for 20 minutes. And that's really good that some of you are identifying if your brain is ready or not. And so that's awesome. So keep that up. And this is just another example of that. Okay. Fermentation, which we've heard about a lot, at least maybe your older brothers and sisters in college have talked about. It's the creation of alcohol. I mean, this is the key. What is the big takeaway of fermentation is that an alcohol is created. How is it created? You have to start with a hydrocarbon. Typically, it's a sugar, but you don't need to know how to identify a sugar, but just giving you more information. But when an alcohol is created and carbon dioxide is created as well, that process is called fermentation. And I mean, as difficult, the difficult level of the Regents is basically to do you one of these or one of these. And if you can identify that the suffix here is an alcohol, or the functional group here is an alcohol, carbon dioxide has been also produced. That's the process of fermentation. I'm trying to keep this as simple as possible. Just a straightforward kind of way to identify. All right. Esterification is exactly what it sounds like. Esterification is the process of producing an ester. And I know a lot of people have had a difficult time with naming esters. And that's to be expected. That's one of the hardest things to do in this unit. But it's not asking you to name anything. It's just asking you to identify. And in both of these scenarios, I'm going to move quickly because it's just, hopefully you get it at this point. But, well, first off, by definition, it's taking an alcohol and mixing it with an acid. And then you get an ester in water. But just like with fermentation, if you can identify the product as an ester, you know how it was formed. So when I look at this condensed formula, I'll give you a little preview into what we'll do later. I see this at the end, OOH. And if I go to my reference table, there's only one type of thing, one type of functional group, one type of compound that ends with an OOH, and that's an acid. This is an alcohol. So automatically, I figured out acid, alcohol. And now what is this? I'm not sure. I have a difficult time with these condensed formulas. Kind of pick up on the clues that are given to you. For instance, there are two O's, two oxygens, located in the middle. Not one, but two. And there's only one class of compound where your two oxygens are centered in the middle, and that's an ester. So you don't have to really be able to pick up on the whole thing. It's just the little clues that are inside. So I know that this formula right here, even though it's condensed, and I have a difficult time with condensed formulas, is esterification, because two oxygens in the middle can only be symbolic of an ester. Now this one gives you a little bit more insight because it shows you these double bonds that are located. And again, you can see that when we take an acid and we take an alcohol and we mix them together, we get this thing. And this thing, just like up here, has two oxygens located in the center of a chain. And only one type of compound can do that, and those are esters. So knowing the definitions is good and great, and memorizing it, but being able to identify products or reactants just by their functional groups will tell you all that you need to know. All right, moving on. This is the last one that's really important, and then the other two are not that big of a deal. You'll see why in a second. So combustion reactions or fire. Fire and your combustion is kind of everything you've grown up with. You know, I know all of you have done a middle school demonstration where you take a match, or your teacher takes a match, they light it on fire, and then they cover it up with something. The flame goes out. And, you know, why is that? Because all fire needs oxygen to breathe. And that's something that you learned a long time ago, but you need to know for identification of organic reactions. Because if oxygen gas is not present in your reactants, then, well, it can't be combustion. And every fire creates carbon dioxide and water. These are my products. Those are my reactants. Okay, and that's just, it has to be that way. So here's my hydrocarbon. Here's my oxygen gas. Here's my carbon dioxide, and here's my water. And that's just combustion. Has to have this, 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 and it has to have something here, but this can change. We can have combustion of alcohols, we can have combustion of ethers, we can have combustion of lots of things, but also we can have combustion of a simple hydrocarbon. Two more. Polymerization is taking a lot of small hydrocarbons and creating one really large one. So we take these little guys here. Take these little guys here. Ethene, 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 and then we create a very long hydrocarbon chain. Now the purpose of this is to make something that is really strong. Plastics are an example of a synthetic polymer. Kevlar, or what's the other one? Dropping off my head. Kevlar and Teflon are also examples of taking small chains of hydrocarbons and creating one long one. And Kevlar and Teflon are substances that stop bullets. Those are the things that are in bulletproof vests. So it's kind of like one of those situations where, oh, that's a great example. If you ever try and take a twig and you try and break one twig, it breaks really easily. But if you stack up more and more and more and more twigs and you try and break that, it becomes much more difficult to do, because the more bonds that are in one substance, the harder it is to snap it apart. So that's what polymerization is, and just being able to identify small chains to create one large one is what we need. And then the last one is kind of silly, but it's really all you need to know for the Regents. So I'm not going to bog you down with the minutia of the molecular formulas and what types of functional groups they are. But there's this reaction called saponification, or as I like to call it, soponification, because that's just the reaction that you need to make soap. And that truly is all the New York State Regents exam needs you to know about that. All right. So, hey, do me a favor, hit the subscribe button, become a follower, get updated every time I post something. And I hope this is working out for you. We are in a weird time, and we got to make the best of it. So, good luck. Make sure you copy the notes, print it out, whatever you got to do. And I'll talk to you later.